Hello everyone, I'm mh6208 and this is the video explanation for homework 3, question number 2. And in this question, we are given that x is a uniform distribution in range AB and both inclusive, and y equal to x squared. For the first part, y equal to x squared is not needed. We just need to use this information to figure it out. And the way we do it is that because it's a new uniform distribution, it has a graphical shape like this. It's just from A to B everywhere have the same value. And we also know that this is the probability density function. This and its probability and its integral, or the summation of every value from A to B, should be equal to 1. So the y value, or let's say the height of this line, is basically just 1 over b minus a. Just basically the same way that you figure out that you have a rectangular shape of area 1, and one side is length b minus a. What's these other sides lengths? Just this part. So we have here everything other than a from A to B is just 0. And for the little fx, the probability density function is really easy, just like this. And for the second part of this question, we need to find the probability distribution function. And it's a little bit complicated because it's basically just an integral of this function with let's just say let's just make sure that this part and this part are covered. So the probability distribution function has anything less than a equal to 0, and anything greater than greater than b equal to 1, and at the b value, the function has exactly equal to 1. The y, well, let's say the y y value. And by in order to obtain the equation for this, we can simply do integration of this. However, there's a there is a after doing the integration, there's a constant that's added after the normal integration part, and that's where this +1 comes from. This value is obtained by well, there are several ways to obtain this. You can the way I did it was plug b in here as x, so it's b plus it's just 1 over b minus a times b plus some constant, right? And that thing is equal to 1. So that I can figure out that this is basically just the constant is just 1 over b minus a. So in the square in the bracket, I can just say a +1 to represent that constant, and that's it. For part B, we are given a equal to -1, b equal to 3. We need to find out because there's a relationship between x and y. We need to find out the probability density function of y and probability distribution function of y. And oops, right, this one. And because we are given that a is -1, b is 3, the relationship between x and y is really just y is less than or equal to 9, larger than or equal to 0. However, from -1 to 0 and from 0 to 1, the x in this range results in the same y. So we can divide this y's range further into two parts. The first part is that where y is less than 1, greater than 0 is caused by this range. X, which x is smaller than 1, larger than -1. And the other part is just the normal y smaller than 9, larger than 1. And that's from x smaller than 3, larger than 1. And we can get 3 cases from this. Case 1 would be this, case 2 would be from here, and case 3 would be otherwise. So the probability this density function should look like this, somewhat like this. So for case 1, let's because the shape of this this equation of this relationship as an equation is basically a concave curve. Let's say it's just a U curve, and is symmetrical. It's symmetrical at the y with the y-axis. So we can just simply look at one side and multiply by 2 is for both sides, right? So by simply looking at one side, considering that x is less than 1, greater than 0, which results in this, but the other side also results in this. Keep in mind that. And fx of x is equal to 0.25. We can get the gx prime, which is basically this part, doing the derivative on both sides, and plug this value in, get this part. This is one side of the U-shaped curve, and which is basically from 1 to 0. We also have from -1 to 0. So we can just multiply this by 2 and get the entire equation for case 1, where y is smaller than 1, larger than 0. For case 2 is much simpler because we already have this. This is no matter, let's say, no matter what, because this is obtained from x smaller than 1, larger than 0, the one side. For case 2, it's also just on this side, and the equation should be the same. So we can just take it and use it over here, and we can then combine for 3 cases and get everything from get the first case, second case, and 0 otherwise. And in order to obtain the probability distribution function, we can simply do the integration. Yes, and it results in 4 cases where, of course, the distribution function at the left-hand side is equal to 0 and the right-hand side is equal to 1. So basically, after doing the derivative, it's just this. Notice that this part has a +1 over 4. This is also the constant that this is the constant, just like over here. You can obtain this value by plugging the numbers and do the calculation. So the shape of probability density function would be like this, because you can just simply use a graphing calculator or something like that, plug in the value, plug in the equation of this and this for the respective range and get this graph. And the other part, you can do the same for the probability distribution function. Just plug in these equations with respect to their range. And of course, I forgot to add this part. This part is 0. For anything beyond this on the left-hand side is 0. So I didn't draw it. And finally, I think there's we need to find the expected value of y. This is pretty much just easy job, but you know, the expected value of anything is just the summation of, let's say, the y is just the summation or the integration of y times is big F y. No, sorry. The times is probability density function. Yes, and by plugging all the values in, this 1/4 from here, this 1/8 from here with their respective range. This integration is from 1 to 0. This integration is from 0 to 9, 9 to 1, and do the calculation for the entire thing, we get 7/3 as the expected value, and that's it.